Hello everyone. In the previous session, I have solved some problems on series combination of resistances and parallel combination of resistances. So based on the voltage divider rule and current divider rule. So next we shall move on to the next problem. So in this problem, the circuit is provided and so we need to find out the potential difference or the voltage, okay, between D to F, okay, and voltage between A to G. So initially to find the voltage between D to F, so we need to find out the currents, okay, what current passes through these resistors. So look at the circuit here. So the direction is provided in the circuit in the first loop, and of course the direction is provided in the second loop. So if direction is not provided in the problem, so you can make your own direction, okay. So according to this direction, so let me call it as I1, and so since we have got two different loops here, I call this current as I1 and I call this current as I2. So initially we need to find out the values of the currents. So now here to find the values of the current, apply KVL to this loop, that is A, B, C, D. So if we apply KVL to this loop, then we get according to KVL statement, so we get 10, which is 10 volts. So look at the polarity here, so minus to plus, so look at the direction of the current here, so we get 10 and minus, so I1 into 2 or 2 into I1 minus 3 into I1 minus 5 into I1 is equal to 0, okay. And further if you simplify this, then so you can shift these three to the right hand side, then we will be getting 2 plus 3 plus 5. So I have taken I1 common here, okay, from these three terms. Then so we get I1 is equal to, so which is 10 volts divided by, so 5 plus 3 plus 2, again we get 10. So finally we get I1 as 1 ampere. Similarly, so we need to find out the value of I2. So apply KVL to this loop. So if we apply KVL to this loop again, so 10, which is 10 volts minus and plus, so minus, now 5 into I2 minus 2 into I2 minus 3 into I2 is equal to 0. So this is according to KVL statement. And further if you simplify this expression, so we would be getting 5 plus 2 plus 3 into I2, and so I2 is equal to 10 divided by 10, so we get 1 ampere. So now we have calculated the value of I1 and I2, and once we simplify or once we find out the value of I1 and I2, then so we need to consider the branch from D to F, okay. So D to F means, so we need to write what are the components comes between D to F, and remember, so you can choose any path between D to F. So that means you can have this path, that is 5 ohm, 3 ohm, 10, then 2 ohm, 5 ohm. So finally you have to reach the point, that is F, okay. So you have to start from the point D and finally you have to reach the point F. So you can consider either this path or you can consider either so this path, or else you can consider so this path. So any path can be considered, okay. For our convenience I am taking this path, okay. So that means from point D, so you can just write down point D, then what are the components comes between D to F. So take 5 ohm here, so we have 5 ohm, and so next I am taking 3 ohm, and so I am taking 10 volts, and this is plus and minus according to the symbol. Then we have one more resistor. So let us consider this path, which is 2 ohm, and the next resistance which we get here as 5 ohm, and this point is F, D to F, okay. So these are the components comes between D to F. Now we need to find out the voltage between D to F, and you know what current passes through this point. Okay, what current passes through 5 ohm and 3 ohm resistances, and you know what current passes through 2 ohm and 5 ohm resistances. Now if you apply KVL to this path, okay, what do we get? Which is 5 into I1, that means VDF is equal to, right, so plus 3 into I1 and minus, because I am considering from D to F, so this will be treated as positive, and since this direction is opposite, so we get minus 10 volt, then plus 2 into I2 plus 5 into I2, right. So we know the values of I1 and I2, so substitute here, we get VDF as, so anyway, so I1 and I2 values are 1 amperes, so here we get 5 plus 3, which is 8, minus 10 plus, and 5 plus 2 is 7, and so if we further simplify this expression, so we get 5 volts, that is VDF. So similarly, as I have calculated the value of this VDF, so you can also try with voltage between A to G. So voltage between A to G means that is from this point to this point. So as I have already indicated, you can choose any path, right. So that means you can choose this path, and or you can choose so this path, or you can choose this path also. Always you choose the path which consists the less number of components, right. Now we shall move on to the next problem, and in the given circuit, so look at the circuit here, this is quite different from the previous problems, and from this given circuit, so we need to find out the current through all the resistors. So current through all the resistors and voltage between A to B. Okay, so you can see here voltage between A to B. So the first part is we need to find out the current through all the resistors and voltage across, or voltage between A to B. So look at the circuit carefully. So in this circuit you can see, so initially 1 ampere, that is, let us consider this as the total current which is entering to this circuit, and the current which is coming out of this circuit, out of this network, is again 1 ampere, again we call it as I, okay, which is the total current. So here the network is given, and the current which is entering the network, that is 1 ampere, and current which is coming out of the network is again 1 ampere. Let us treat this as a total current. So and according to the direction, so here in the given circuit the direction is provided because we have got two different loops here. Okay, if direction is not provided, as I have already indicated in the previous problems, the direction can be chosen. Okay, so you can choose the direction. Now according to this direction, so let me consider this current, the current which is entering, the current which is passing through 10 ohm as I1. So here I am just assuming the different currents, so later we need to find out these currents, and so before that you need to satisfy KCL, that is Kirchhoff's current law. Okay, that means the current which is entering the network, right, so which is equal to the current which is coming out of the network. So okay, so let us consider this current as I1, and according to this direction, now so I1 is passing through this junction or through this resistor. Now let us call this current as I2. So since we have two different loops, I have taken two different currents, I1 and I2. So now this current is entering this junction and this current is leaving the junction. Now the current which is passing through 2.5 ohm as I1 minus I2. Okay, so we are just trying to satisfy KCL statement, Kirchhoff's current law. So I1 current is entering this junction and I2 current is leaving the junction. Then so this current, the current which is entering 2.5 as 2.5 ohm as I1 minus I2. Okay, now so the current I is entering the junction and current I1 is leaving the junction. Now I treat this current as, so remember current I is entering and I1 is leaving the junction. Now I treat this current as I minus I1, right. So now we have just identified what current passes through these resistors, but still we have not yet calculated the value of I, but we are just finding out what current, okay, what current passes through these resistors. So I minus I1. Now, okay, so now I minus I1 current is entering the junction, I2 current is also entering the junction. Now let us call this current as I minus I1 plus I2. So why it is plus I2? Because I2 current is also entering the junction. So here both the currents get added. So I minus I1, so we have this plus I2. So and look at the direction. So this current is entering this junction and this current is also entering the junction. Then so what is the equation here? What equation we get? I1 minus I2. So remember, both the currents are entering the junction. I1 minus I2, then plus I minus I1 plus I2. So what happens here? You have minus I2 and plus I2. So I2 gets cancelled and you have minus I1 and plus I1. So I1 gets cancelled. So finally what current we get? We get only total current. See, we get the total current. So this is how we should satisfy KCL statement, right? So what KCL states here? The algebraic sum of the currents. Algebraic sum of the currents which are meeting at the junction is equal to 0, or so algebraic sum of the currents entering the junction is equal to algebraic sum of the currents leaving the junction. So now we have satisfied this statement, KCL statement. Now we need to find out these currents, and to find the values of the current we need to apply KVL. So let us apply KVL to this loop first, that is CDAC or ACDA. Fine. So let us apply KVL to the loop, that is C, D, A, again C. And now if we apply KVL to this loop, so what do we get? So I2 into 5, or so 5 into I2. Now here see, we are just moving in this direction, so even this in the same direction, so we should take positive. Now so look at the direction. So now in this direction, if we move to this direction, so what is happening? So look at the direction of the current and look at this direction, so both are opposite. Then we should take minus 20 into I minus I1. Okay, 20 ohm into I minus I1. Next, so of course the direction of this current is in the same direction of this I1. So what happens here? Plus 10 into I1 is equal to 0. Okay, so let us call this expression as 1, right? So here we have applied KVL to this loop, that is CDAC. Now we have got this expression, so we need to simplify this expression. And next, in the next case, if we apply KVL to the second loop, so that means, so look at the direction C, D, B, C. So C, D, B, C. So if we apply KVL to this loop, then so we get, and look at the direction of the current. So this current means this is in anti-clockwise direction. So this I2 current is also in the same direction of this. Then we can write this as 5 into I2. Okay. Then so look at the direction. So both are in the same direction. Then plus 5 into I minus I1 plus I2. Okay. Now, so what about this point? This direction is opposite to this direction. Then we can have this as minus 2.5 into I1 minus I2. So you have to be careful while substituting all these values. So which is equal to 0. Let us call this equation as 2. After simplifying equation 1, now so we have got equation which is 30I1 plus 5I2 is equal to 20. So let us call this equation as 3. And so now if we simplify expression 2, so we get 7.5 I1 minus 12 I2 is equal to 5. So we have called this as equation 4. So now we have equation 3 and 4. Okay, so now we need to simplify these two expressions, and here so you can just ask where is this value I, because directly or straight away you can substitute I as 1 ampere as as it is given here I is equal to 1 ampere. So I have substituted the value of I as 1 ampere, and finally you got these two expressions, so 3 and 4. And finally we have to find out the values of I1 and I2 by using simultaneous equation. So after simplifying these two expressions 3 and 4, so we get I1 as 0.666 amperes and I2 as 0. Okay, so after simplifying equation 3 and 4 using simultaneous equation, so we get I1 as 0.666 amperes, I2 as 0. So after calculating the values of I1 and I2, so we need to calculate the current through all the resistors, right? So current through all the resistors means, let me take the first one as current through 10 ohm resistor. So current through 10 ohm resistor. So what is the current through 10 ohm resistor, which is I1? So you can write I1. And so current through 2.5 ohm resistor, which is I1 minus I2. And current through 5 ohm resistor, because there are two 5 ohm resistors, so I have just mentioned this as C to D. So current through 5 ohm resistor is I2, and current through 20 ohm resistor is I minus I1, and current through this 5 ohm resistor, which is I minus I1 plus I2. So I minus I1 plus I2. So anyway we have calculated the values of I1 and I2, so you can substitute all the currents here, then you will be getting current through all the resistors. For example, in the first part, so 10 ohm resistor, current through 10 ohm resistor is I1, so I1 we have got as 0.66 amperes, and similarly I1 minus I2. So since I2 is equal to 0, so we have only I1, which is again 0.6. So similarly you can calculate the rest of the values. So in the next part, so you need to find out voltage between A to B. So voltage between A to B. So what are the points like A to B? So A to B. And to find the values of A to B, so you need to have the path between A to B. So for example, if this is A, then you need to check what are the components comes between A to B. And as I have explained you in the previous problem, you can choose any path between A to B, but always we should prefer the path which consists of less number of components. Here, so A to B means we have 10 ohm resistor, and so we have 2.5 ohm resistor. So here I have taken this path which consists of two components, 10 ohm resistor and 2.5 ohm resistor. So what is the current passes through 10 ohm resistor, which is I1, and the current which passes through 2.5 ohm resistor is I1 minus I2. So I1 minus I2. Since I2 is equal to 0, the same current, I1 current passes through 10 ohm resistor and 2.5 ohm resistor. So now we get VAB as, so this voltage across this point, let us consider this as V1, and voltage across this point as V2. So we get V1 as, so 10 into 0.666 amperes, we get 6.666 plus, and V2. Okay, so V2 is nothing but what? 2.5 into I1 minus I2. So 2.5 into only I1, because I2 is equal to 0. So we get this as 1.666. So finally we get this as 8.33 volts. Okay, which is the voltage across A to B. So now I will be solving the next problem. So in this given circuit, so we need to find out volts, I1, I2 and I3, and power supplied by IA, right? So look at the circuit carefully. Again, this is different from the previous problems. So initially we need to find out the value of volts, that is voltage, right? So next we need to find out I1, I2, I3, and the last part is power supplied by IA. So power supplied by this IA. So there are two current sources. So one is IA and another one is IB, and IA, IB values are given here. IA as 5 amperes and IB as 3 amperes. To find the value of volts in the first case, so we need to find out the values of I1, I2 and I3. Okay. So now I am going to apply KCL to this circuit. Look at the direction of the currents here. So look at the direction of IA and IB. So direction of this IA, IB are in this direction, and the direction of I1, I2, I3. So which are in this direction. And so apply KCL to this circuit. So if we apply KCL to this circuit, then we know that algebraic sum of the currents entering the junction is equal to the algebraic sum of the currents leaving the junction. So now these two currents are entering this junction. If I consider this as the common one or the common junction point, so these two currents are entering the junction and these three currents are leaving the junction. So according to that, so we can have the equation as IA plus IB, because both the currents are entering the junction is equal to, so three currents are leaving the junction, which are I1 plus I2 plus I3, and we can substitute the values of IA and IB, because IA, IB values are provided 5 plus 3. So I can write this as 8 is equal to I1 plus I2 plus I3. Okay, let us call this equation as 1. And so you know that when the resistors are connected in parallel, voltage across all the resistors are same. So voltage across this point is same as voltage across this point, and which is also same as voltage across this point. So I can write voltage which is V is equal to 2 into I1 is equal to 4 into I2, which is also equal to 8 into I3. Okay, so remember, when the resistors are connected in parallel, voltage across all the resistors remains same. So 2 into I1 is equal to 4 into I2 is equal to 8 into I3. So, and using this expression, and before that let us call this equation as 2, and using this expression I am going to replace this I2 and I3 in terms of I1. So once again let me repeat. So I am going to substitute I2 and I3 in terms of I1 using equation 2. So how can I substitute I2, I3 in terms of I1? So we can have only this expression. So these two expression, which is 2 into I1 is equal to 4 into I2, because I need to replace this I2 in terms of I1. So what do I get? I2 is equal to 2 by 4 into I1, or this can be written as 1 by 2 into I1. Okay, now I am replacing I2 in terms of I1 here, and so I am going to replace this I3 in terms of I1. So how can I do that? So you can have this equation and this equation, which is 2 into I1 is equal to 8 into I3. So what is I3? I3 is equal to 2 by 8. Okay, 2 by 8 into I1, or I3 is equal to, it is 1 by 4 I1, which is I3. So now I am going to replace I2 and I3 in terms of I1 using these two equations. Then we can have this equation as 8 is equal to I1 plus. So what is I2 now? I2 is equal to 1 by 2 into I1. So 1 by 2 into I1 plus. So what is I3? I3 is equal to 1 by 4 into I1. So 1 by 4 into I1. So you can simplify this expression, then you get I1 value. And once you get the I1 value, you can substitute I1 value here to find the value of I2. So remember, once you find the value of I1, you can substitute I1 here to find the value of I2. And once the I1 and I2 values are calculated, of course you can also calculate the value of I3, that is by substituting the value of I1. So in this way we can calculate I1, I2 and I3. Right? So in this way we can calculate the values of I1, I2, I3. And once you calculate the values of I1, I2 and I3, so how we can calculate the voltage? So you know that voltage can be 2 into I1 and or 4 into I2 or 8 into I3. So you can have any expression. So voltage is equal to, voltage can be anything. So I am taking 2 into I1. So you can also calculate the value of V, voltage. And finally power supplied by IA. So what is power supplied by IA? So you can have power supplied by IA, power is equal to, we know that, which is V into IA. So anyway you are going to calculate voltage from this expression and substitute voltage, and the current value is given here because current value is 5 amperes. You can also calculate the value of power supplied by IA, right? So now we shall move on to the last problem in this particular chapter. And so look at the circuit carefully, and this is almost similar to the second problem which I have solved in this session. In the given circuit, so we need to find out current in all the branches. So all the branches means, so you can see here the direction and which is indicating here, so 0.02 ohms. So here they have not mentioned in terms of the resistor, but the value which is indicating in terms of ohm, it is understood that there is a resistance between this A to B and there is a resistance between B to C, and similarly C to D, of course, because the values are provided here which is in terms of ohms. So from D to E and E to F. So only here the resistance is given in terms of this. So which is 0.02 ohms. So the question is, so we need to find out the current in all the branches. So that means current through 0.02 ohm, that is from A to B, B to C, C to D, D to E and E to F, finally F to A. Okay. So to find the value of the current in all the branches, so we need to apply KVL to this loop, and before that you need to find out what type of current passes through it. Okay, so that means before you find the value of the current, so we need to find out what current passes through all the resistors. So based on the currents which I have shown here. Okay, so initially to start with, so let us consider from point A, and the current which is passing through this resistor, I am just assuming this as current I. I am just assuming the current as I. Okay, and remember you can start from any point. Okay, you can start from any point in the circuit, but here I am considering from this point A. So and consider this as the total current which is I, and I current is entering this junction and 60 ampere is leaving the junction. So now look at the circuit carefully. I current is entering the junction and 60 ampere is leaving the junction. So when I current is entering the junction, 60 amperes is leaving the junction, then what is the current here? So I minus 60. So remember, the current which is passing through 0.01 ohm is I minus 60, right? Because 60 ampere is leaving the junction. Now I minus 60 is entering the junction and 60 amperes is also entering the junction. So both the currents are entering the junction. Then so we call this current as I, total current. Right, because what happens here, so we get I minus 60 and plus 60, so 60 gets cancelled. Finally we get the total current, that is I, and so I current is entering the junction and 120 amperes is leaving the junction. Then we call this current as I minus 120. Right, I current is entering and 120 current is leaving the junction, so I minus 120. Now I minus 120 is entering the junction, 70 current is also entering the junction. So we call it as I minus 120 plus 70. The current which is passing through 0.01 ohm is I minus 120 plus 70, because 70 current is entering the junction. Now so here we get this as I minus 50. So we get I minus 50. I minus 50 is entering the junction and 30 is leaving the junction. So 30 amperes is leaving the junction. Now So we get the current which is passing through 0.02 ohm as I minus 50 minus 30. So straight away I write this as I minus 80. So now I minus 80 is entering the junction and 80 current is also entering the junction. So both the currents gets added. So finally we get this current as, see, because 80 minus 80 and plus 80 gets cancelled. So finally we get this current as I, which is the total current. Okay, so this is how we need to analyze the circuit. So once we know what current passes through these resistors, now we can apply KVL to this loop. So later we can find out the current. So now apply KVL to this loop. So this loop means that is A, B, C, D, E and F. So apply KVL to this loop. So if we apply KVL to this loop, so let us start with point A, which is I into, so 0.02 ohms. So 0.02 ohms into I plus, so now this becomes 0.01 ohms into I minus 60. 0.01 ohms into I minus 60 plus, so now look at the next part. So 0.03 into I plus 0.03 into I plus, so next 0.01 into I minus 120. So 0.01 into I minus 120, next plus, so 0.01 is the resistor value into I minus 50 plus, now 0.02 ohm into I minus 80 is equal to 0. So now we need to simplify this expression. So finally we get I as 39 amperes, right? If we simplify this expression, so we get I as 39 amperes, and once we find the value of the current, which is 39 amperes, so later we can find out so what current passes through each resistors, right, through each branch. So here current from A to B, so current from A to B is equal to I. Okay, so current through A to B, which is I, and similarly current through B to C. So B to C is I minus 60, and so current through C to D is only I again. So D to E is I minus 120, and from E to F I minus 50, and from F to A I minus 80. So you can simplify the values here, and from A to B, which is directly 39 amperes, and similarly I minus 60, so it is 39 minus 60. So you can simplify this, and similarly you can simplify the currents through all the branches. Thank you.